Well, we've learned that corresponding parts of congruent triangles are congruent. And now we're over here looking at, in this chapter, both the proving triangles congruent using side, 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 and side, angle, side. We're looking here at side, side, side. And on page 265 in example 2, we were asked to graph some triangles given some coordinates, which I have done here as you see. So we got this J coordinate at 2, 5. That's what we have here. K is at 1, 1. And L is when X is 5, Y is 2. So there's this triangle, and then the second triangle, which is over on the left, when N is -3, when X is -3 and Y is 0, that's point N. Point P is where X is -7 and Y is 1. And Q is where X is -4 and Y is 4. So we have those points. We've connected those with line segments. And that was the first part of the problem, just to actually go in and graph that. And I used GeoGebra as my tool to graph that, so I could show this to you. You might be using graph paper, or even putting in grid lines into a OneNote page. You can do it that way as well. That would be 3 different methods, or find some other type of graph paper that you could do online. Now, the second thing we're asked to do is, after we've got the graph, is to look at those and see if it would appear that these triangles are congruent. Well, they, in just looking at them, they look about the same. But if we're going to prove them congruent using side, 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 we would need to identify our corresponding parts. Now, looking at this triangle on the right, I see that point J is kind of the high point, and point K is the low point on the coordinate plane. And looking at this second triangle, the one on the left, it would appear that here Q is the high point and N is the low point. So I might then make a conjecture that the corresponding parts are segment JK. And I'm wondering if those are equal or congruent to segment QN. And let's see, going back to the right, if I look from J to L and Q to P, well, those look like corresponding parts, so I would want to know what's the distance in between what's the distance of segment JK, and is that equal to QP? And then lastly, that would leave me with these segments down here. Let's see, let me do this. We'll do it like this. Let's say we start with JK and QN. Let me do it like that. JK. We want to know if that is equal to QN. And then we would be looking at JL to QP. And then lastly, we would want to consider, let's say, LK to PN. Now, we're going to go over here to the next slide, and we're going to use our distance formula to determine that. But now remember what our distance formula is. It is, on the coordinate plane, this is square root of x2 minus x1 squared plus y2 minus y1 squared. Square root of all of that will give us the distance of these various segments. So let's see if these corresponding parts, JK and QN, and then the corresponding parts JL and QP, and then the corresponding parts LK to PN, see if they do in fact have the same length or measurement. And if they do, then these triangles are congruent. All right, well, first let's go about this and let's find the distances of our various line segments. And we're going to first take up JK. So remember, our distance formula is the square root of, and we got JK, so I would have x2, I'd be using the k coordinates as my x2s. So I got 1 minus 2 squared plus, and then my y coordinates, 1 minus 5 squared, taking the square root of that. And let's see, 1 minus 2 is -1, so that's -1 squared, plus 1 minus 5 is -4, that's -4 squared. And so then we've got -1 squared is 1, and -4 squared is 16. And so we've got the square root. So segment JK is the square root of 17. All right, now let's look at QN, because that's the one that we thought looked to be a corresponding part. And so again, we're going to take the square root of, and I got Q and N, so N is going to be my Y2s, X2, I mean, let's say, so I got -3 minus -4, that's going to make that a plus, squared, plus 0 minus 4 squared, taking the square root of that. Well, let's see, -3, this is going to make that a positive, plus what? So that's going to be 1 squared plus -4 squared, 0 minus 4, -4 squared. And of course, we got 1 plus -4 squared is 16. And that equals the square root of 17. So our first corresponding parts, JK and QN, both have the same length. And so there's 1/3 of our side proven. Now let's look at JL. All right, same way. I'm taking the square root. I'm going to use L as my 2 coordinates, J as my 1 coordinates. So I've got 5 minus 2 squared plus 2 minus 5 squared, square root of all that. Let's see, 5 minus 2 is 3, so that's 3 squared, plus 2 minus 5 is -3 squared, square root of that. So now I'm looking at the square root of 9 plus 9, which is the square root of 18. And I could actually simplify that further. Could leave it right there at square root of 18, but square root of 18 is the same as square root of 9 times the square root of 2, which then would equal 3 square root of 2. Either square root of 18 or 3 square root of 2 would be a valid answer. Now let's look at segment QP. So now my P's are my 2 coordinates, Q's are my 1. So I've got the square root of -7 minus -4 minus -4, perhaps I should say, squared, plus 1 minus 4 squared, square root of that. Okay, so let's see, -7 minus -4, and that's going to be -7 plus 4, so that's going to be -3 squared, plus 1 minus 4 is -3 squared, which is then 9 plus 9, or the square root of 18, or as we further simplified that, 3 square root of 2, as we did over here on the left. All right, so our second side lengths, corresponding parts, then appear to be congruent, equal to each other. Let's take on the last one. So let's say LK. We'll start with that. So my K coordinates are my number 2's and my L's are my number 1's. And so we're going to say the square root of 1 minus 5. Here the K1 L5 squared. And plus, using the y coordinates, 1 minus 2 squared. Talking about the square root of that. And so then we got the square root of 1 minus 5, which is negative 4 squared, plus 1 minus 2 is negative 1 squared, which then is equal to the square root of negative 4 squared is 16, negative 1 squared is 1, or the square root of 17. And we're going to finish this off to see if segment PN is actually equal to segment LK. And so my N's are my number 2, coordinates, my P's are my number 1. So we got the square root of negative 3 minus 7 squared. I need another parentheses right there. Plus 0 minus 1 squared, square root of all that mess. So let's see, negative 3 minus negative 7, so that's negative 3 plus 7, so that's going to be 4 squared, plus 0 minus 1 is negative 1 squared, and 4 squared is 16, negative 1 squared is 1, and we've got the square root of 17. So we can finish this off then by saying, going back to what my triangle was, JKL, QPN, no, QNP. So then I could say that triangle JKL is equal to triangle QNP. Side, 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 corresponding parts of congruent triangles are congruent.